the racing line, ideally, is the fastest path to follow on a race course, okay? So to run a race, you want to have the what? The shortest, obviously. The distance is the same around the track, right? But who wins the race? In track and field, right? In race cars, in horse racing, it's the shortest time. But it's not the straightaway, you guys remember? It's the what? It's the cornering speed, okay? Racing is one of the turns. So if time is distance over velocity, rearrange the equation, you have to get the shortest distance with the highest speed. The problem is, usually you have to trade off the two, right? If you want to take a turn wider, it's a greater distance, but you can have a higher speed. If you take a turn really tight, yeah, it's a shorter distance, but you usually have to lower your speed. So usually you want to try to balance out those two factors, okay? Since a tire slips fast on short, tight turns, you have high, it's called centripetal. It's a fancy word, okay? Actually, you know what? I don't have quite enough room to write it here. I'm going to write it up here. Centripetal. Big fancy word. Centripetal acceleration. Centripetal is a fancy word. It's Latin for center seeking. So when you go in a circle, you feel like you're flying to the outside of the circle, but ironically, there is no force pushing you outside. There's only a force to pull you into the circle. Centrifugal force is a fictitious force. It's fake. It doesn't exist. It feels like you're going to the outside of a turn. And there's only two factors. It's the velocity squared over the radius. So all that is to take a turn, the faster you go and the tighter the turn, the more force it takes. So it's harder to take a turn really fast and really tight. So you have to balance those factors out, okay? So a lot of corners, you win them. The idea, it's called straightening the corner. You take the turn wide, you aim it inward at what's called the apex, and then you kind of want to whip out like a rubber band there.